Today we're ready for Lesson 4.3, and you can see our title. The goal today is to try to get you to think now about the importance of saving for the future. So you can see we're saving for the long term. We're building that nest egg. You may think that you got plenty of time for this. You're still young. You're still in high school. But I want to plant the thought in your mind about how important it is when you do have that opportunity to get that first job out of college. Even now you can be saving, but especially when you get that first real job that we would call your first job out of college, doing what it is that you are planning to do. Starting then in your early 20s, and develop a plan where you're saving regularly for the day when you eventually would like to retire. Recent statistics say that around 43% of Americans today, these are 2025 stats, have no retirement at all. And even those who have worked some toward planning and saving for retirement, about 60% of Americans say they're way behind. So that's something I would like for you to avoid, and you can start thinking about that now, planning now for that time when you are able to have a plan in place where you can prepare for your future. So let's just start off. This is an article, as you can see, that came from Jessica Summerfield. I'm just going to summarize 4 retirement tips that young adults can start implementing now. And the first one we would say is invest early, no matter how small. Some people think, well, I don't really have much, but just begin with something, and then as time goes on, hopefully you can build on that. But train yourself to begin early with an investment, a regular investment, and then hopefully plan on building on that as you get older and as the opportunity arises. Number 2, we'll talk a little bit about 401ks in the next slide, but if your employer doesn't offer a 401k, probably heard of 401ks before, and again, we'll go into a little bit more detail about what this is all about. If they don't have a 401k, not all employers do, most of them do, I guess, but if they don't offer one, then you can open up your own IRA. IRA stands for Individual Retirement Account. Number 3, keep your 401k untouched. If you are able to contribute, it's not like a savings account. It is meant for you to, again, we're thinking long term. You should not withdraw from this. You get penalized if you withdraw before your age 59 and a half, and there's pretty steep penalties. But again, this is a mindset of you're wanting to have that nest egg for the time when you're not able to work any longer because of old age. And then finally, remember, the future is important. Just don't want you to get caught like so many are today, just being unprepared. Okay, so just some general tips. Want to plant the seed in your mind how important it is for you to start thinking now and start planning now, and then you'll be ready to put your plan into action here, hopefully, Lord willing, in the next few years. Okay. Okay, here's this 401k I was talking about, the advantage of having a 401k. So the way a 401k works is you have an arrangement with your employer. If they offer one, you will elect a certain amount of money to be taken out of your check every pay period. And they have an investment place, a financial company that will take your money, and they've got some different options. You can even get involved in that and how your money is invested. A lot of times they've got some pre-packaged plans that are a little riskier when you're younger, because you can afford to be risky when you're young. Let the market work for you. Again, you're thinking long term. You shouldn't get too excited if the market, a lot of these are investments in stocks, and the stock market can be on a roller coaster from time to time, but you're thinking long term, and you can afford to, ride the waves a little bit when you're young. As you get older, you want to be less risky. You don't want to take a huge hit. We are familiar with people that were just about ready to retire, and because the stock market crashed back in 08, 09, it really caused them to delay their retirement for several years. And so as you get closer to retirement, you want to move your money into less risky, more stable, interest-bearing financial vehicles. But when you first start out, the risky, no risk, no reward, that kind of saying. So here's an example. A person making $3,000 every paycheck. If you participate in a 401k, they're going to take that $300 out of every check, and then the amount that you're actually going to be taxed on will be the $2,700. So we say a 401k allows you to have a deferred tax situation, or we call this pre-tax dollars. The $300 that you're taking out isn't taxed now. The idea is it will be taxed when you do start to withdraw from the account when you are at retirement age. And hopefully at that time you're going to be in a lower tax bracket, making less money, so you won't have to pay quite as much tax at that point. But again, that's way down the road. In the immediate, you're saving some tax money. So look at the difference here. The income tax for the person that participates in the 401k, he's paying $351. I just approximately 13% of your pay will go to income tax. Versus the person who does not participate, he's going to pay $390 in income tax. Now, this person does have his own IRA. Okay, doesn't have anything to do with your employer. They're not going to take anything out of your check. That's just going to be money that you set aside. You pay it in yourself every month. But notice the advantage. My take-home pay is more because of this amount that's taken out of my check. I'm paying less in taxes. I get to take home more money than I'm investing the same amount, but the advantage of deferred taxes is quite a bit. It's pretty significant, and that is a big advantage of a 401k. And then another advantage is a lot of employers, I would say most employers, have a match. And I would say at a very least they match 2% of your salary. So that means if you're making, for this person, this equates to $72,000 a year. And 2% of $72,000 divided up by 24 pay periods, assuming they're paid semi-monthly, they're going to get an extra $60 in addition to the $300 you're putting in. They're going to put $60 in per pay period. So that's quite an advantage over many, many years. That's quite a bit of money that your employer is putting in on top of what you're contributing. So the bottom line here is when you go ahead and start planting that seed of when you're looking for work, when you're looking for that first job out of college, you should ask, do you have a 401k that I can participate in, and do you match a certain percentage? And if that's the case, that's something that you really should get involved in yourself and then take advantage of the employer matching privilege. Okay, so let's just take a look at some math behind saving regular amounts monthly. Okay, so how does this work? We've looked at in the past, we've looked at just taking one amount and how one deposit would grow with compound interest over time. And that's just one deposit. How much did it become at the end of a certain period? Well, this is regular amounts being deposited. So let's look at the power of saving regular amounts monthly. So we're going to put $100 in a savings account at the end of each month. The account pays 1% on the account each month. That's a monthly rate. So the APR is really 12%. So again, that's just 12% divided by 12. So let's see what this looks like with interest and the regular deposit being made. Just kind of give us an idea of the math behind formulas that we're going to be looking at in just a bit. Okay, so this first month we don't have any interest. We just made our first deposit. So we have $100 in the account. So for month number 2, we're going to have 1% being applied on that $100. So it's applied on the previous balance. So that's $1. We make another deposit. Every month we're making the same deposit. So at the end of month 2, we have our 2 deposits plus the dollar that we've made in interest. So we now have $201 in the bank. So for month 3, we do 1% of that balance, and that's $2.01. We make another $100 deposit, and so now we do the ending balance for month 2 plus the interest, 201, plus our monthly deposit for month 3. Now we're up to 303.01. And now you can kind of get a pattern going here. We do 1% of that balance, and that's going to be 303. Another deposit. So previous balance plus interest plus deposit gets us up to 406.04. And then we could keep on going, but I think you get the idea. The interest is applied to the balance at the end of the previous month, and we won't go forever here. So another deposit, and now at the end of month 5, we now have $510.10. Okay, so that's the idea. At the end of every month, we have a new balance. That new balance is what interest is applied on, interest paid on the previous balance. Every month we're making that same deposit. So you can see we're growing at a pretty fast rate, obviously, because we're making regular monthly deposits and we have compound interest working in our favor. And so our balance is going to grow pretty quickly. And you can imagine what this does over many, many, many years. So just think, if you started at 24, even just putting in $100 in an account a month, in 40 years, you can just imagine how much money you would have. And that's certainly doable. Probably even more than that over time. You can deposit even more. That's the kind of thing that I want you to be thinking about in this lesson. Well, we did some longhand math on saving regular amounts monthly. Well, here's the official formula that you're going to be using to come up with that balance after T monthly deposits. Okay, so let's just use this formula to do a couple of examples. Here's our first example. We have a savings account earning 7% APR. Okay, we deposit $20 to the account at the end of each month for 5 years. What is the future value? And that's just saying what's the account going to be worth after 5 years of doing this consistently. All right, so notice the balance after T monthly deposits, and we got 5 years, so that's going to be 60 deposits. So let's see, our balance is going to be the deposit, which is 20 times 1 plus, and I'm going to do what we've done in the past. We're given this percentage as an APR, but we need to divide that by 12 and raise that to the 60th power minus 1. And then the rate is again going to be 0.07 divided by 12 in parentheses. So going to our calculator, that $20 being deposited, just $20 every month at this rate for 5 years, you're going to have an account that is equal to 143,186. So you should make sure you're able to do that successfully with your calculator. And then here's another opportunity to practice this formula. This time we have $40 being deposited every month, and it's a 4% APR. All right, and so we go to our calculator, and we're going to come up with this amount. I just realized as I was keying in my calculator, I left off a very important exponent here. It's 10 years, so that should be 120 months. So going to your calculator, you should end up with 5,889.99. All right. Now, sometimes we need to use a formula to tell us if we know what our end goal is, how much does that mean we're going to have to put in each month? So we're kind of turning this formula around a little bit. So this is an important formula to kind of give us a way to plan ahead. So let's do this example. Younger brother, we want to have 10,000 so he can start college in 5 years. We have a 7.2% APR. How much does that mean we're going to have to deposit each month in order to reach that goal? All right, so needed monthly deposit is our goal, which is 10,000 times the rate, and again that's APR divided by 12. And we're going to divide that by 1 plus the rate. And this is again 5 years, so that's going to be 60 months. So let's go to our calculator and see what we come up with. And hopefully you successfully came up with a monthly amount of $138.96. That's how much will be needed each month in order to end up with $10,000 at the end of 5 years. So let's just run through that formula again with this other example. We have our goal of 50,000, 9% APR, one plus our 9% divided by 12. And this is going to be 18 years, so 18 times 12 is 216 minus 1. So again, let's go to our calculator. And we got $93.22. All right, just turning the formula around, if we know what we want to end up with, we can plan on how much we need to deposit each month. All right, again, saving for retirement, big key in this lesson. So let's see, suppose that you'd like to retire in 40 years and you want to have a future value of $500,000 in a savings account. Your employer makes regular monthly deposits into your account. You're going to expect an APR of 9% for your account. How much do you need your employer to deposit each month? So that's going to be basically that same formula that we used on the previous slide. Our needed deposit is going to be the goal. So just so you can look at that again. How much do we need? That's going to be our goal times the rate. All right. So our goal is 500,000 times the rate, our 9% APR. All right. Divided by 1 plus the 9% divided by 12. And this is for 40 years, so 40 times 12, 480, raised to the 480th power minus 1. So let's see what we get when we calculate this. And we got, our employer would need, in order to get that 500,000, we would need 106.81 deposited or invested each month. All right, letter B says the formulas we have been using assume that the interest rate is constant over the period in question. That's unrealistic. It's going to fluctuate. Over a period of 40 years, though, interest rates can vary widely. To see what difference the interest rate can make, let's assume a constant APR of 6% for your retirement account. That's a pretty good average, I guess, over a 40-year period. How much do you need your employer to deposit under this assumption? So we're just going to take those same numbers, but we're going to change the percentage, just lowering it by 3 percentage points and seeing how much that's going to affect what needs to be deposited each month. Oh, it should be 6. Okay, let's go back to our calculator. And hopefully you came up with 251.07. So you can see just a slight drop in how much we're earning, 3%, really increases the amount that's going to be needed each month. So the interest rate is huge. Obviously, we want to choose investments that will give us as high a rate as possible, but this is one of the things that you have to kind of work through over a 40-year period, especially if you're dealing in stocks or other equity type investments where the markets swing widely, and that can really have a bearing on how much you end up with in retirement. So good little exercise there. Okay, now let's talk about annuities. What are annuities? Well, let's identify some terms first. Your nest egg. I've been talking about your nest egg. That's the balance of your retirement account at the time of retirement. So you're done working It's been 40, 45 years down the road. What is it that you have in your account that you can rely on to get you through the remaining years? Obviously, we don't know how long that is, but we need to have money to take us through the end of our days. And then the monthly yield. Monthly yield. That's how much you're going to withdraw, or you'll be able to withdraw from your account each month. Okay, and there's a couple of different approaches to this. You could have what is known as a perpetuity. A perpetuity this is where you're drawing each month, but only on the interest that you've made. So you want to leave the principal amount untouched. So each month you're earning interest money, and that's the only thing that you would withdraw to actually live on. Obviously, you would need to have quite a bit of money in your account in principal in order to make enough interest money to live on, but this is an option that some people choose if they do have a pretty high amount saved in their nest egg. And then this annuity that we've mentioned in our title, that's an arrangement where you're basically withdrawing both principal and interest. So maybe you're not able to, the interest alone isn't enough, and so you can have an annuity, and you just want to make sure that your account is large enough to carry you again, take care of your needs until you are no longer here when the Lord takes you home. So interesting here, annuity works just like an installment loan, except we're basically paying ourselves. The installment loan is being paid to us instead of us paying for some sort of payment, car payment or house payment. So that same formula that we used back in lesson 4.2 for finding the amount of an installment loan is going to be used for an annuity that we basically pay to ourselves. So here it is, the monthly annuity yield, how much we're going to be able to take each month from our account. So that probably looks familiar. That's the same formula that we used previously. So let's take a look at it. We have a nest egg of 800,000 with an APR of 6% compounded monthly. How much are we going to be able, this monthly yield, how much can we take out each month for 20 years? Okay, we're just going to assume that we're going to have a 20-year lifespan. We obviously don't know that for sure, but we're just going to guesstimate that it's going to be a 20-year period that we want to draw on this beyond our working years. All right, so let's take a look. We have 800,000. And we're multiplying times the rate, the APR, and multiplying by 1 plus the rate. And that's going to be raised to the 20 times 12. And this would be raised to the 240th. So let me go ahead and make this more like what we're going to key into our calculator. Just a little review of what we did previously. Don't really need multiplication here. I'll clean this up a little bit. All right. And then we're dividing by 1 plus raised to the 240 minus 1. And in your calculator, hopefully you were able to, once you key this in, you'll be able to come up with 5,731 and 45 cents. So what that's saying is, for a 20-year period, if you had this much in your nest egg, you would be able to, assuming you're going to make the 6% on it, you would be able to take out this much to live on every month for a 20-year period. All right, let's try another one. We have a nest egg of $1 million. And 6%. For 25 years, so 25 times 12, 300. All right, and then we're going to be dividing by 1 plus 0.06 divided by 12 raised to the 300 minus 1. So let's go back to our calculator and see what this looks like. And we came up with 64.43 and 1 cent. Okay, very good. And then we can turn this around. If we know what we are going to have each month, what does that mean? This is what we want to have each month to be able to live on. What does that mean our nest egg total needs to be? So we're just turning this formula around a little bit. So we have our $4,000 yield. Okay. 1 plus the 5% APR. And 20 years, again, this would be 240, 20 times 12. And then 0.05 divided by 12. One plus 0.05 divided by 12 raised to the 240. All right, let's take a look at our calculator and see what we come up with. So our calculator tells us that we would need a nest egg of 606,101 and 25 cents to be able to draw $4,000 a month over a 20-year period. All right, let's practice that one more time, and this will be the end of our notes. So if we want to be able to take $5,000 a month, 9% APR, 25 years, again is 300. .09 divided by 12. All right, let's take a look. So we would need a nest egg to be able to get $5,000 a month for 25 years. We would need a nest egg. Now the rate's really good, 9%, so that means our nest egg can be a little lower than the previous example, which was 5%. So 595, 808, and 11 cents. Hopefully you were able to use the formula successfully and come up with that number. And that is it. That's for our notes. You should be prepared now to work the problems that have been assigned. And if there's anything I can do to help you, please let me know. I'll see you next time.